For activity 3, you're going to be making molecular models using the models that are in your lab. It will be useful to take all of the parts of your model set out and inspect them and make sure that you identify what each individual part represents. So, for example, if your central atom has 2 electron domains or 2 charge clouds, you will use this white with 2 prongs. If your central atom has 3 electron domains, you'll use the dark brown with 3 prongs. If your central atom has 4 electron domains, you can use any one of these colors. Black tends to represent carbon, red represents oxygen, blue represents nitrogen, and green will represent the others. But all of these have 4 prongs, which signifies 4 electron domains or charge clouds. If your central atom has 5 electron domains or charge clouds, you'll use the purple, and if it has 6, you'll use the silver, which has 6 prongs. And then to represent a lone pair, we have these paddles here that will fit directly into whatever your central atom is. These little bead-like things with one little insert are used to be the outer atoms. White typically represents hydrogen, and I didn't include the white tubes here, but the white tubes represent the bonds and will connect the outer atoms to the central atom. You will be making models for the 9 compounds that you chose for activity 1, and there is a chart in your lab manual, but I think the chart that I made for you might be easier to use. So here's the chart. It has an extra column to include the chemical formula, and here's my example, the sulfur dioxide. And before you even make the model, what I would do is I would identify the domains or the charge clouds on the central atom and the lone pairs on the central atom. And you do that by looking at the Lewis dot structure that you wrote for activity 1. So in the data table for activity 1, here's my Lewis dot structure for sulfur dioxide. And to count the charge clouds, I merely sum the outer atoms and add any lone pairs. So I have 2 outer atoms and 1 lone pair, so I have 3 electron domains. You can do that for every molecule that you have. Just sum the outer atoms plus the lone pairs on the central atoms for your charge clouds or electron domains. Once you have identified your domains on the central atom and the lone pair, then you know which central atom to use. So since sulfur dioxide has 3 electron domains, this is the model I'm going to use for my sulfur. Also, once you identify the electron domains and the number of lone pairs, this table in activity 3 will let you know what the molecular geometry is and what the bond angles are for each one of your molecular models. Now, in the directions for activity 3, it tells you to use 2 tubes and 2 prongs on each atom for a double bond. We're not going to do that. It is absolutely fine just to use 1 tube for a double bond. So let's take a look at the model that I made for sulfur dioxide. So here's the 3-pronged central atom, since there are 3 charge clouds or 3 electron domains around my central atom. And each oxygen is represented by the same color. Since oxygen is not my central atom, I'm not going to use the red. You totally could, but generally for those outer atoms, we're going to use these little beads because we don't really care about them as much as we do the central atom where the electron pairs are going to impact the geometry. So in my 3-prong, I have my 2 bonds to oxygen, and then I have this paddle, which represents this lone pair. You will also take photos of your models, and you can take 9 photos individually, or you can put several on one piece of paper. It is helpful to have the Lewis dot structure near it, so you can make sure that you have the domains correct. You definitely need to have the chemical formula, so I know which chemical this model is supposed to be associated with, as well as your name. So going back to my table, the geometry of sulfur dioxide is bent and its bond angle is less than 120. I can find that on this table here because I, excuse me, I knew that there were 3 electron domains around the sulfur, 1 lone pair, so this is the molecular geometry. It's bent and less than 120. And the reason it's less than 120 is this lone pair is kind of diffuse, and so it repels these bonding electrons more than a bond would. So this angle between the 2 sulfur-oxygen bonds is less than 120. It's being pushed down by this lone pair. So as it states in the instructions, label each model. It says photograph for future reference. Actually photograph it for your grade. So photographs of your 9 models and their names and your name, or by name I mean the chemical formula, is going to be part of your grade. And then it tells you right here to sketch a perspective drawing of each compound, and if necessary, use wedges and dashes. So that's what this last column in data table 3 is. These arrows here actually come from activity 4. I'll get to that later. And because this is all in one plane, there really isn't much perspective. So notice that with the line drawing, I didn't even put any lone pairs on my outer atoms. My E represents my lone pair. I'm just putting a line to my outer atom to kind of show the geometry. And this is where the less than 120 bond angle is.